Hello everyone. Today we are going to discuss about Bode plot in control system. Okay. So Bode plot, it is a frequency response plot in control system. So we have a number of plots. It is one of the most important plot even in the design of control system. Okay. So Bode plot consists of two graphs. One is a magnitude plot, another one is phase plot. Magnitude plot is the plot of magnitude of sinusoidal transfer function versus logarithmic frequency. And phase plot is the plot of phase angle of the sinusoidal function versus logarithmic frequency. So both the plots, magnitude as well as phase plots, characteristics are used to describe the frequency response. The magnitude of the open loop transfer function is found by using this formula. Okay, m equal to 20 log mod g of j omega into h of j omega. It is represented in decibels. Okay, phase angle of the open loop transfer function is phi. It is denoted by phi. That is nothing but angle of g of j omega into h of j omega. Okay. The advantages of Bode plot. Advantages, we have many advantages compared to other frequency response plots. It is based on the asymptotic approximation, which provides a simple method to plot the logarithmic magnitude curve. Basically, it is an approximate curve. Freehand also we can draw after finding the values. It is a simple method to draw the magnitude plot. Next one is multiplication of various magnitude appears in the transfer function can be treated as addition, while division can be treated as subtraction in the logarithmic scale. Because in the transfer function sometimes numerator or denominator you have multiples of terms. So at that time if you are taking multiplication in the numerator or denominator, you will be treated as addition. If it is suppose the function it is numerator by denominator, at that time you are treating as subtraction. It is easy to draw the plots. With the help of this plot, we can directly comment on the stability of system without doing any calculations. Once we are drawing the plot, easily from that we can find the stability of the system also. And next one is study of relative stability is easier as parameters of analysis of the relative stability are gain margin and phase margin, which are visibly seen on sketch. After drawing the Bode plot, we can see the gain margin and phase margin in that graph only. From that we can see and we can study the relative stability. It is easy because all are in the same graph only. And we can represent low values as well as high frequency values in a single diagram. In the Bode plot, we are using Similog paper. So there we can take low values, very low also, and also high values we can represent in that graph. Transfer function can be easily obtained from the magnitude curve of the Bode plot. Okay, so these are the advantages of Bode plot. Now, the procedure for drawing the Bode plot, because here we have two plots. One is the magnitude plot, another one is phase plot. First we will see the magnitude plot. Whatever the transfer function given in the examination or anywhere, that should be in terms of S only. First step is we need to convert into frequency domain. After substituting S equal to j omega in the transfer function, it will convert into j omega. So then after that we have to find the corner frequencies. Thereafter you need to find, that is you need to put the marks in graph paper. After finding the corner frequencies, then these are the basic important factors you need to keep in the order, moving from top to bottom in the given sequence only. That if you are taking first one, you have to take constant term, then you take as an integral factors. We can say here in terms of s 1 by s, that is a pole at origin, right? Or 0 also, because if you are taking s, it is in the numerator. If you are taking 1 by s, it is the denominator. Similar way, it is a plus or minus n I have taken here. It may be 1 by s square or s square, 1 by s cube like. So, it is an integral factors. Or derivative factors also you can take if you are taking, for example, if you are taking s. So, that should be derivative factor. Okay. If you are taking here, for example, it is a s square, right? If you are taking 1 by s square, so both are there here. One is this one is a numerator, and here this term it is in the denominator. So these are the poles and these are the zeros, right? Derivative, second derivative here you will get. Then you have to take first order terms. It is like standard form, 1 plus ht, right? So 1 plus j omega t. It may be in the numerator or denominator. You need to see, okay, which one it is in. In this order only you have to take. After that, you have to take second order terms. Okay. So after taking that, based on the corner frequencies, it should be in increasing order. Then you have to draw the line with the help of corresponding slope of the given factors. So at the corner frequency, slope is changing. So that means by adding slope of that next factor, it is automatically it will add. How it is in the examples, I will explain how to calculate the values. From this, we can find the magnitude plot. You need to follow these steps. Similar way, for drawing phase plot in the Bode diagram or Bode plot, so these are the simple way we can calculate. It is not that much tough compared to the magnitude plot, because we are using similar paper, but the way of calculation, it is very easy. It is like a normal graph paper only. First you have to find the expression for this, that is a phase value phi. You can take that is the phi value you have to find. So after finding the phi value, just to take different values of frequencies, including corner frequencies. Different values of frequencies, find the angle. So just note down those. So on x-axis it is the frequency, y-axis and the angle. Just put the points or mark the points on the graph. Just connect those points, you will get the phase plot. It is a very easy. So after that, we can find the phase margin, gain margin, phase crossover frequency, gain crossover frequency in the graph itself. So this way we can draw the Bode plot, magnitude plot as well as phase plot. Okay.